we are going to move right into Unit 6. Now, mind you that the first 3 units that we worked on were, we were taking a look at what is chemistry? What is chemistry? And what are atoms and how do atoms play a role in compounds? In Unit 4, we took a look at what are compounds, how do we name them, what are some of the properties of compounds. Unit 5, you took a look at gases, and gases behave very differently from all other types of, all other, what do I want to say, phases of matter. And so they warrant their own discussion in looking at gas laws. And hopefully, when you were doing the work for gas laws, that you remembered, hey, wait, I know some of this stuff. This makes sense, because you should have some experience with gases, whether in, let's say, you know, car tires, bike tires, certain different things, right? So now moving into Unit 6, now we're going to start taking a look at mixtures and a special kind of mixture called a solution. So I'm going to share my screen. And we are going to take a look at mixtures, solutions actually. So what is a solution? The learning objectives we're going to cover is distinguish between heterogeneous and homogeneous mixtures, looking at solutions. We're going to describe the properties of a solvent and solutes in a solution. We're going to distinguish between solutions and colloids. We're going to predict whether a solution is formed based on relative polarity and intermolecular forces between solute and solvent. We're going to define the properties of a solution, including miscibility, saturation, and solubility. We're going to look at the effect of temperature changes on solubility of a solid solute. And we're going to look at the change of pressure and temperature on a solubility of a gas. So don't forget what we learned about gases when we get to that part. So what are the things that you should likely review to be prepared for this unit is to take a look back at pure substances versus mixtures in Unit 2, vapor pressure in Unit 2, and where we just left with ions and ionic compounds, and even covalent compounds as well, because they can make solutions too. So we are going to distinguish between heterogeneous and homogeneous mixtures, describe the properties of solvent, and distinguish between solutions and colloids. So here we have a schematic, and it's something that can help you determine whether you're looking at a solution or a colloid. So let's say we have a mixture. Is it uniform? If it's yes, then we have a homogeneous mixture. And depending on what the solute, the size of the solute, you'll either have a solution or a colloid. If the mixture is not uniform, it's most likely a heterogeneous mixture and not a solution. Excuse me. All right, so what is a solution? A solution is a homogeneous mixture of 2 or more substances. And the way that a solution forms is when there are attractions between the solute and solvent molecules. So what we have here in this image is a mixture of water and salt. At this point in time, we don't actually have a solution. And can anyone tell me why that this picture that we're looking at right here is not actually a solution? Anybody? Go ahead and let's see, raise your hand and I'll call on you. Anybody have any idea? Go ahead, Rahat.
I guess because we haven't started the solution and like it's not evenly distributed.
Exactly. Vivian, what would you like to add?
I was going to say the same thing. Yeah, it's not.
Go ahead. I'm sorry.
It's not mixed together properly yet.
Yes, it's not mixed together properly yet. So it's not exactly a solution, but it does gives us some information about what the solute and the solvent are. So there are always going to be two components in a solution. The solvent is present in larger amount, and it's the thing that does the dissolving, or something gets dissolved in it. And the solute is present in the smaller amount, and it's the thing that gets dissolved. Now, we tend to think of solutions as only in a liquid state, the final state of the two substances coming together as a liquid, but it doesn't have to be. We know of other solutions that you might not even think of. So let's see what's on the next slide. So here are some different kinds of solutions. We have gas in a gas. So air is a type of solution. Because it's uniform, we can't tell the oxygen molecules separate from the nitrogen molecules. It is a solution. A gas in a liquid is like soda. Gas in a solid, where we have palladium metal, we have hydrogen in it. Liquid, so gasoline that you put in your car is a mixture of different hydrocarbons. Hydrocarbon, what do you think those compounds are made up of mostly? Anybody want to take a go at it? Raise your hand. We have some answers in the chat. Let's see. Yes, hydrogen and carbon. Cool. So the gasoline that we use is a mixture of a number of different, where octane is the highest concentration. A liquid and a solid, where if you have silver cavities, well, not silver cavities, but silver fillings, it's mercury and silver. So mercury is the liquid and silver is the solid, and a solid and a liquid is what we mainly tend to think of when we think of solutions, where you have a solid that you dissolve in a liquid, and seawater is one of those, and a solid in a solid. So brass is a solid solution. Gold is a solid solution. So gold is not pure. Pure gold is 24 karat gold. And if you have 18 karat gold, you have a higher concentration of gold than the other metals, right? And 24 karat is 100% gold. All right. So what can solutes be? Solutes can either be a liquid, a gas, or a solid. And what happens is that they're evenly spread throughout the solution, and it mixes with the solvents, so that if I have a solid solute in a liquid solvent, the final state, right, is the same physical state, right? So if I take salt and I put it in water, right? The salt was a solid, water is a liquid, but by the time everything is mixed in the solution, it's a liquid, right? And that's what this statement means. The solute and solvent have the same physical state. So a solution cannot be separated by filtration. So solutes cannot be separated by filtration. If you take salt water and you pass it through let's say a coffee filter, you'll still end up with salt water in your coffee pot, right? But they can be set. So if it's a liquid solution, the solute can be separated from the solvent by evaporation. You cannot see the solute particles within the solution, although it can give color to the solution. So if it's like a blue solute that you dissolve in water, it can turn the solution blue. Okay. So an example of that is if I have copper sulfate, which are the blue molecules down here, well, the blue substance down in the bottom, as it dissolves in water, notice that the water turns blue, and we see the copper sulfate ions are floating around in solution. Notice that this is just a model showing that they are evenly distributed, whereas in this first model, we see that the salt is tightly packed, and that's why it's down at the bottom. Over time, the solid will dissolve if you just leave it alone. Stirring helps to mix a solid solute. Also, there are some other things that help a solid solute to dissolve or mix. All right, so here's another type of, here's another table showing the different types of solutes and solvents. So we have a gas solution, and hold on right quick, folks.
Ashley Nicole, I love your background. I had to say that. Another one of my favorite professors. Good choice.
All right. All right, I'm back, folks, I'm back. Okay, so here we have another set of examples of types of solutions. So if I have a gas solution, I have a gas and a gas. Notice that some liquid solutions can be a gas in a liquid in a liquid, or a solid in a liquid. Anybody use ammonia to clean? Notice that ammonia is a solution of gaseous ammonia in a liquid water. So when you use ammonia, has anyone ever noticed that when you open the top of the ammonia, as soon as you open the top, what happens? What happens as soon as you open the top? Let me see what's in the chat. The smell.
No.
Right? So what do you think that smell is? Why do you think you automatically smell it? What do you think is happening there? The gas is doing what, Vivian? Yes,
Releasing.
the gas is escaping.
It's releasing.
Yes, so the gas is being released from that liquid. Funny story. My son is so weird. My oldest son, I don't know where he came from, but one day he decided he wanted to sniff. He wanted to see what vinegar smells like for real, and put his nose at the top of the container and sniffed it. He was like, "Mom, I promise you, I will never sniff anything in my life." So maybe he needs to do that. He won't do cocaine or anything like that. So yeah. So no, I don't know where he came from. I know I made him and all, but I don't know where he came from. All right, so notice that you can have a gas in a liquid in a liquid, and a solid in a liquid, and the solution itself will be a liquid. That's important to note. So solutes and solvents can be either a solid, a liquid, or a gas, right? And the final form or the final state of the solution will be based on, mainly is going to be based on the solvent, because it's always going to be in higher amount. So we can classify homogeneous mixtures as either a solution or a colloid. So sometimes you have a colloid, and a colloid has particles that are dissolved, but they're larger than the solutes that are in solutions. So it's still going to be a solute and a solvent, but the difference between a solution and a colloid is that the particles that are dissolved are larger. And in a colloid, light can be scattered by the particles that are dissolved, right? So what is the difference between the two? Well, the solution is transparent, and you can't separate it through filtration. And you can't separate it actually unless you evaporate or do something to the solution. It contains really small particles like ions or molecules that can't be filtered. The difference between a colloid in a solution is that the solutes in a solution can pass through a semi-permeable membrane. And why does this even matter? So our cells are surrounded by semi-permeable membranes. Actually, that's what holds all the stuff in a cell together. So solutions, the particles that are in solutions can pass through these membranes, whether it be like glucose or anybody ever done the experiment where you you have this little plastic tube and you put it in a solution, and inside the tube, it's got starch in it, and you put iodine in the water, and then the iodine can go into the little plastic tubing and it turns the starch black because there's an interaction between the iodine and the starch, but the starch doesn't come out into the water. Well, the starch is a colloid because it's a much larger particle. And so it will not be able to go through the membrane, right? So colloids have larger particles, and that's the major difference between a solution and a colloid, is that colloid particles cannot pass through semi-permeable membranes, but solute particles can. And that's how we have salt transfer, different things between our blood and our tissue cells, gases and that sort of thing. So here we have some examples of colloids in solutions. And so colloids have a substance that is dispersed, and that would be the solute. And then the dispersing medium would be the solvent. So like mayonnaise and homogenized milk, you've got in milk, you've got fats, you've got sugars, you've got proteins, you've got all of those things that are dispersed in that medium. And the fat is the liquid that is homogenized. You know what homogenization means? It simply means that they shake the hell out of the milk so that you don't separate. So if anyone has ever breastfed or you've seen someone breastfeeding, if they pump some milk, they sat it on the table, the fat ends up on the top and then the liquid part is on the bottom. Cow's milk does the same thing. The reason why it doesn't look like that in the milk that you buy in the store is because they put it in a homogenizer and it shakes, shake, 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 shake until those two liquids are completely dispersed within each other. And fats are really big molecules, right? So blood plasma is another example of a colloid. How we doing on the chat, Rihanna? We good?
Yep. All good.
So Simone, different sizes of particles for categorizing mixtures. Which particle size should we refer to? I'm not gonna test you on the size of particles, but what I would want you to know is the difference between the properties, right? I would never test you something as simple as, oh, this one has a particle that's a 0.2 nanometers and this one is 500 nanometers. Which one is it? That's just too simple of a question, and that's not what I would ask you. All right. All right. At least not on an exam. Maybe in a practice question, but not on an exam.